Hello everyone, welcome to Hydropower. Today we are discussing about the hydropower. We'll discuss about the basic introduction and its scenario in Nepal. So today we'll be talking about the basic introduction of hydropower, types of hydropower plants, historical background of power development in Nepal, hydropower potential in Nepal and world, as well as the hydropower development policy in Nepal. So let's start from the introduction. Hydropower is renewable energy resources that uses the energy of flowing or falling water to generate electricity. It involves building a dam to create a reservoir, directing water through a turbine which rotates and powers a generator to produce electricity. Hydropower is clean, reliable and sustainable, but it can have environmental and social impacts. The hydropower plants are of two types, that are conventional hydropower and pumped storage hydropower. So let's talk about the conventional hydropower. It refers to the generation of electricity from the gravitational forces of flowing or filling water. It is one of the oldest and most widely used forms of renewable energy. There are some key points about conventional hydropower. How it works. This plant is typically consisting of a dam. The water is stored behind the dam, creating a reservoir. When released, the water flows through turbines which spin and drive generators to produce electricity. The amount of electricity generated depends upon the volume of water flow and the height of the dam. Reservoir. The creation of a reservoir is a significant feature of conventional hydropower. It involves the flooding of a large area upstream of the dam, forming a artificial lake. The stored water can be released as needed to generate electricity, control downstream water flow, or provide irrigation and drinking water. Capacity and output. Conventional water plants vary in size and capacity, ranging from small-scale installations to large-scale projects. Large dams can have a significant capacity and generate large amounts of electricity. The output is determined by the design of the plants, including the flow rate, height, and efficiency of the turbines. Conventional hydropower. Environmental impacts. While conventional hydropower is a renewable energy source, it can have environmental impacts. The creation of reservoirs can lead to habitat loss, displacement of communities, and alternation of natural river ecosystems. Dam may also disrupt fish migration and affect downstream water quality and sedimentation patterns. However, with careful planning and mitigation measures, some of these impacts can be minimized. Advantages. It is a reliable source of electricity as it depends on the constant flow of water. It produces clean energy without direct greenhouse gas emission, contributing to the reduce of carbon dioxide emissions. Hydropower plants have long lifespan and can provide electricity for many decades. Challenge. Building large dams and reservoirs for hydropower project can be capital intensive and requires significant initial investment. Environmental and social consideration need to be taken into account to minimize negative impacts. Additionally, the availability of suitable locations for new hydropower projects may be limited in some regions. Global uses. Conventional hydropower is widely used globally and has been a significant contributor to electricity generation in many countries. Some countries such as Norway, Canada, Brazil, Nepal, India rely heavily in hydropower for a sustainable portion of their electricity needs. Pumped storage hydropower. Pumped storage hydropower is a type of hydropower that uses the energy of water to store and generate electricity. It involves two reservoirs located at different elevation and a reversible turbine system. There are key points about pumped storage hydropower. How it works. Pumped storage hydropower works by using two reservoirs, an upper reservoir and a lower reservoir, typically located at different elevations. During periods of low electricity demand or when there is excess electricity in the grid, the system pumps water from the lower reservoir to upper reservoir using electricity to drive the pumps. Power generation. When there is a high demand of electricity or during peak hours, the water is released from the upper reservoir back to the lower reservoir through the reversible turbine system. As the water flows down, it passes through the turbines which generate electricity. Efficiency. Pump storage hydropower systems are known for their high efficiency. The energy required to pump water uphill is often provided during periods of low demand when electricity is cheaper. Energy storage. The main advantage of pump storage hydropower is its ability to store energy during off-peak hours. When electricity demand is low, excess electricity from other sources such as wind or solar power can be used to pump water to the upper reservoir. The stored energy can then be released and used during peak hours or when there is high demand for electricity, providing a reliable and flexible source of power. Environmental consideration. While pumped storage hydropower does not directly produce greenhouse gas emissions during operation, the construction of the reservoir and infrastructure can have environmental impacts including habitat disruption and land use changes. However, these impacts are often less significant compared to conventional hydropower since the size of the reservoir is generally smaller. Global use. Pump storage hydropower is widely used around the world. It is particularly valuable in regions with high penetration of renewable energy sources as it helps in intricate and balance the intermittent nature of these sources with the overall electricity grid. This one is the bonus point for continental hydropower and pump storage hydropower. Now we go to the historical background of power development in Nepal. In the early initiatives, Nepal's Power Development Office begins in the early 20th century. In 1911, the Phurphing hydroelectricity power plant with a capacity of 500 kilowatts was commissioned near Kathmandu. It was the first hydroelectric plant in Nepal and second of South Asia that provide electricity to Kathmandu, capital city. Nationalization. In 1950s, the government of Nepal began nationalizing the power sector. The Nepal Electricity Corporation (NEC) has established in 1956 as a state-owned utility responsible for power generation, transmission and distribution, foreign assistance and IPPs. In the 1980s and 1990s, Nepal sought foreign assistance and introduced the concept of independent power producers (IPPs) to produce private sector involvement in power generation. The government aimed to attract investment and expertise through partnership and domestic and international private companies. Electricity Act 2049. In 1992, Nepal introduced the Electricity Act 2049, which brought significant reforms to the power sector. This act provides a legal framework to private sector participation, encourage competition, and establish provision for licensing, traffics, and regulation. The act aimed to produce investment, efficiency, and sustainability in the power sectors. Large-scale projects and IPPs. The Electricity Act 2049 facilitates the development of large-scale hydropower projects through the participation of IPPs. IPPs are private entities that develop, own, and operate power projects under long-term agreements with the government or the state-owned utility. The approach has allowed for the increased power sector involvement and diversification of power generation sources. Cross-border cooperation. Nepal has actively engaged in general cooperation for power development. It has collaborated with neighboring countries like India, China, and Bangladesh to explore cross-border power trade and develop joint hydropower projects. The power trade agreement with India have been facilitating power exchange and collaboration. Renewable energy focus. In recent years, Nepal shifted focus on renewable energy, including hydropower, to meet energy demands sustainably and implemented policy to promote clean energy development. Hydropower potential in Nepal and world. Let's talk about the hydropower potential in Nepal. Nepal is known for its abundant hydropower potential due to its mountainous terrains and numerous rivers. It is estimated that Nepal has a hydropower gross potential of around 83,000 megawatt, making it one of the countries with the highest hydropower potential in the world. But technically, potential power is about 42,000 megawatt only. However, currently only a fraction of this potential has been trapped, with installed capacity standing at around 1895 megawatt as of 2:38 p.m. 2023 7:10 on NEA.org.NP. Energy details. Nepal has been actively pursuing the development of its hydropower resources to meet domestic energy demand and potentially export electricity in neighboring countries. And now talk about the potential worldwide. Hydropower is the largest source of renewable energy for electricity generation globally. According to estimates, the world's technically feasible hydropower potential is around 15,000 gigawatts, although only a portion of this potential has been developed. Various countries around the world have significant hydropower potential, with notable examples including China, Brazil, Canada, the United States, Russia, and India. Hydropower has been harnessed extensively in these countries and contributes a substantial portion of their electricity generation capacity. The potential hydropower, the hydropower can be generated using formula as shown in the figures. Let's say as shown in your display screen. You can calculate the power of any hydropower project using this calculation, or let's say formula. Now we go to the hydropower development policy in Nepal. Hydropower development policy in 2058 BS. The hydropower development policy 58 BS provides a strategic framework for the development of hydropower project in Nepal. It promotes private sector investment, energy security, and sustainability and inclusive hydropower development. Electricity Act 2049 BS. The Electricity Act 2049 introduced reform in Nepal's power sector. It facilitates private sector participation, competition, and regulatory mechanism for power development, operation, and regulation. Electricity Rules 2050 BS. The Electricity Rule 2050 BS provides detailed guidelines and procedures for the implementation of the Electricity Act. They cover aspects such as licensing, traffic, power purchase agreements, and technical standards in the electricity sector. Water Resource Act 2024 BS. The Water Resource Act 2024 BS established the legal framework for water resource management in Nepal. It addresses water utilization, irrigation, hydropower development, and environmental protection. Water Resource Act 2050 BS. The Water Resource Act 2050 BS is an amendment to the Water Resources Act. So BS, it incorporates provision for environmental conservation, public participation, and coordination among different sectors involved in water resource management. Water Resource Rules 2050 BS. The Water Resource Rule 2050 BS provides detailed regulations and procedures for the implementation of Water Resource Act. They cover aspects such as water use permits, environmental impact assessment, and water resource planning. Environmental Protection Act and Rule 1997. The Environmental Protection Act 1997 provides the legal framework for environmental protection and conservation in Nepal. It aims to ensure sustainable development, pollution control, and environmental impact assessment for various projects, including hydropower. The Environmental Protection Rule provides specific regulations and guidelines for implementing the provision of the Environment Protection Act. They address issues such as pollution control, waste management, and environmental impact assessment produced. Foreign Investment and Technology Transfer Act 1992-80. The Foreign Investment and Technology Transfer Act 1992 encourages foreign direct investment and technology transfer in Nepal. It provides a legal framework for foreign investors, including those interested in hydropower sectors. Nepal Electricity Act 1984. The Electricity Act 1984 laid the foundation of the regulation and development of the electricity sector in Nepal. While it has been superseded by the Electricity Act 1049 BS, it played a significant role in shaping the early stage of Nepal's power sector development. Independent power producers IPPS. Nepal has encouraged the participation of independent power producers in hydropower development. IPPS are private entities that develop, own, and operate hydropower projects under long-term agreements with the government or the state-owned utility. This approach has increased private sector involvement and diversification of power generation sources. So today we will end up the session for this month, and we will come back with the next new video in a few days. Till then, thank you for watching this. See you in next video. Thank you.